Next, we move on to visualization. So we began this by basically importing map.lib.plt as PLT, importing C1 and SNS. Then we move on to printing out the summary stats for the key numeric fields. So numeric columns is equal to total sales, total quantity, total profit, and order count. Print complete DF num columns that describe round 2. Basically what this block of code does, it basically selects like the main numerical columns over here, and it basically prints out their statistics summary, such as like their count, their mean, their standard deviation, and like their maximum and the 25% quartiles to all the way to like 75% quartiles. Then we move on to plotting the correlation heat map with plt.figure size 8 by 6. Then afterwards we create like a heat map visualization with complete df.numeric columns.correlation. Basically this calculates the pairwise correlation between the numeric fields and basically visualizes them like as a heat map with like annotated values over here. Then afterwards we title this visualization and then we plot it. So here's our output for this. So here's the columns of total sales all the way to order count. Here's their count, their mean, their standard deviation, there's minimum, there's 25 percentile, 50 percentile, 75 percentile max. Then we move on to like the correlation heat map visualization. So in this visualization, we can see that the darker it is, it has like a higher correlation as opposed to lighter it is. So for example, something like total quantity has like a higher correlation with like order count as opposed to something like total profit, which has a less of a correlation with order count. So yeah. Next we move on to distributions. So fig axis is equal to plt.subplots 1, 2, 1, 3, fig size 18, 5. Basically this creates like a figure with 3 side-by-side plots, for each with their own axis. Then afterwards we move on to SNS, history block, complete DF total sales, bins is 50, KDE is true, and AX is equal to axis of bracket 0. Basically, this plots like a histogram with like 50 bins and the kernel density estimate of like the daily total sales, and this like the same thing done but for the total profit section. And then we move on to SNS history plot, complete DF is equal to order count, bins is 30, KD is true, axis is equal to axis 2. Subtitle is order count and distribution. Basically, this block of code basically plots like a histogram of like the numbers of order per day, as this basically helps us visualize the typical order volume. So here's our visualization for total sales, total profit distribution, and order count distribution. So for total sales distribution, we can see that most days have like lower sales, as evidenced by like the long tail over here. And the overall distribution is right skewed, meaning a few days have like a much higher sales than average. Then we have the profit distribution over here. Basically the profit distribution is centered around like 0, with both like positive and negative values over here. Most of the days there's like small profits, but there are days when it goes like with negative profits, and days with like high profit. Then we have the order count distribution over here. So most days have a low number of order, as seen over here, with like the count dropping off quickly as the number increases basically. And this distribution is right skewed, basically showing that high order dates are basically rare. Next I move on to box plots by weekdays and month. So TMP is equal to complete df.copy all the way to TMP the month is equal to TMP date.dt the month name. Basically this makes a copy of like the complete df data over here, and then adds the columns of weekdays and months for each of the date, and this allows for like grouping and visualization of sales by like the weekend and like the month. Next we have fig axis equal to plt.subplots 1 and 2, fig size is equal to 18 and 6. Basically this creates like a figure of like 2 side-by-side plots. Then we have SNS box plot of data is equal to TM, X is weekdays, Y is total sales, order is equal to Monday all the way to Sunday, and axis is equal to axis brackets 1 all the way down to axis brackets 0 dot tick parameters, axis is equal to axis brackets rotations 30. Basically what this block of code does, it basically plots a box plot showing the distribution of like the sales data for each of the day of the week from like Monday to Sunday, and this reveals to us which days tend to have like higher or lower sales. Then we move on to month order. Month order is equal to January all the way to December, all the way down to like PLT axis brackets 1 till tick parameters axis equal to x and rotation 45. Basically, this creates like a box plot showing like the distribution of like the daily sales for each month of for each month in the calendar order from January to December. So here's our visualization for this. So sales by day of the week and sales by month. So over here we can see that Mondays and Fridays have like a slightly higher median, and have more more extreme outliers, while something like Wednesdays have like a lower median and lower outliers, as it's like the middle of the weekdays. So basically, people won't be as so people are pretty busy as compared to like the days of like Mondays and Fridays. Then for the sales by month, we can tell that the median sales tends to increase towards like the later months from like September to December. However, earlier months such as like January to April tend to have like lower median sales and fewer outliers. This is probably like a result of later months from September to October having like slightly more significant holidays such as like Halloween, Thanksgiving, Black Friday, and Christmas, which explain the increase in total sales.